Okay, here we go. What I'd like to do is show you how to find the x-intercepts, the end behavior, and the multiplicity of each x-intercept, or 0, of this equation. So this one I think automatically gets everybody's attention because you see fractions, you're like, too hard, don't want to deal with it. Well, actually, maybe not even too hard, but too much work, right? I hate doing fractions. I always forget adding, subtracting, multiply, blah, 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 blah. The main important thing, ladies and gentlemen, that I like to do is when I'm going to be using my fractions, I like to get rid of them. And I'll show you how to do that in just a second. But before, we can do the end behavior without caring if there's fractions, decimals, whatever. It doesn't matter for end behavior. For end behavior, all we're concerned about is the degree and the leading coefficient. So the degree in this polynomial is 2, and the leading coefficient is 1/2. And the reason why we don't care if it's a fraction or not, because all we're concerned about is it positive or is it negative. So my degree is going to be even, so that's going to tell me that my graph is either going to go both up or both down. Since my leading coefficient is positive, that means my end behavior is going to rise left and rise right. All right? So now the next thing we need to do is we need to find the x-intercepts. And remember, when a graph crosses the x-axis, it crosses the x-axis when f of x equals 0 or when y equals 0. It's really the same term as both your output. So therefore, I can now represent f of x as 0. So I can say 0 equals 1/2 x squared plus 5/2 x minus 3/2. And the nice thing about these fractions is they all have the same denominator. And I like that because I can all get rid of them by multiplying by the same number. A lot of times when you have different denominators, remember you have to multiply by the least common denominator or the least common multiple of all your denominators to get rid of it. Here, they all have different denominators, so we can just multiply everything by 2. And you got to just make sure that you always, when applying this to get rid of fractions, you multiply every term by 2. And what you'll notice is each one of these 2's are going to cancel out now. 2 times 1 divided by 2 equals 1. 1 times x squared is just x squared. So really cancel out's not the best term, but you can see what's happening. So therefore I have 0 equals x squared plus 5x minus 3. All right, so now we have a couple options that we can do to solve this. We can look at completing the square, as we've worked before. We can work at factoring to see if that's going to work, or we can also look at using the quadratic formula. So I'm not really going to want to use completing the square for this one. I could, but I see 5 divided by 2 is just going to give me a fraction. And since I don't have another fraction over here, I don't really want to keep on adding fractions. So I'm going to avoid completing the square. Next thing I look at factoring. Is this factorable? Is there what two numbers multiply to give you -3, but add to give you 5? I'm not seeing it factorable. So what I'm going to want to use is the quadratic formula. So remember, the quadratic formula is opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So simplify this a little bit. I get 25. Let's see, positive 12 divided by 2. I'm sorry. Still equals. And there we go. We continue on. We get -5 plus or minus the square root of 37 divided by 2. I'm not really seeing where this can be simplified with there. So I'm just going to leave my 2 zeros as x equals. So my 2 x-intercepts are going to be x equals -5 plus or minus the square root of 37 divided by 2. Now we need to look at the multiplicity. And since I'm not having the same 0 and it's not being multiplied by by 2, if you look at multiplicity, a little bit harder to show these at these factors because I'm not writing them as factors. But since these are both unique and we're not doubling them, these multiplicities are going to be 1. So we can just write multiplicity. And what you want to do to kind of see that is write them out as each factor, but you can see there's 2 different unique factors, just kind of like x minus 3 and x plus 3. And since they're both unique factors, they're going to have an exponent only of 1. And remember, that's going to be a multiplicity of 1. If it was like x minus 2 squared, that would be a multiplicity of 2. But anyways, that's going to be your final answer. I hope that helped you out. And then you could see I don't really want to get into the graphing. That's going to be a little bit difficult for me to examine without a calculator here in front of you for this video. But there's a quick little video for you. Hope helped.